second lesson of chapter 1. We will going to continue the series of our quick review lectures. In a prior lecture, we have talked about quite a bit. We have talked about different class of solutions and mixture and how to identifying solid and solvent, then how to identifying or how to make a distinguish between them. For today, we have another classification of the solutions, which is very important for the other chapters, classifying aqueous solutions based on the electric conductivity. It means we have some solutions that can conduct electricity and some of them cannot. Some of solutions can conduct electricity, but some of the solutions cannot conduct the electricity. Okay. A solution that can conduct electricity called electrolyte. But not electrolyte, it means cannot conduct electricity. So let's talk about them. What is the point? What's the key of understanding here? Look, about the electrolyte. Electrolyte is a substance. We have some solid substance. When we dissolve in the water, then this solution, this aqueous solution can conduct electricity. So for electrolyte, electrolytes are substances that can dissolve in the water to form a solution, to give a solution that can conduct electricity because of they can produce negative and positively charged particles. So what is the responsible things of the electricity conductivity ion? Mobile ion, positive and negative ions. So if a substance dissolved in water and produces ions, the solution or this substance is an electrolyte because of the solution can conduct electricity. In contrast, we have non-electrolytes. For example, when we're going to dissolve some substance in the water, but that substance cannot produce or do not produce any mobile charged ion particle, so it's non-electrolyte and the aqueous solution cannot conduct electricity. Okay, so please memorize them. Acids, bases, and salts are the electrolytes. Acid, base, and salts are the electrolytes. Acid, base, and salts are the electrolytes. Well, acid strong or weak? Both of them. For base, strong or weak? Both of them. About the salt, well, actually we don't have completely non-dissolved salt. At least any salt can dissolve by a little amount. That's why salts are electrolyte. But for non-electrolyte, we have alcohols such as ethanol, methanol, and sugars. When we dissolve sugar in water, look, when we talk about water, I mean distilled water, deionized water. This is a special kind of water prepared after a special treatment using a reverse osmosis technology in our laboratory to obtain a water that cannot conduct any electricity because we are removing all the ions. So if we dissolve any substance in that kind of water and it do not form any particle, any movable particle charged ion, so this is non-electrolyte. But if we dissolve some substance that gives an ion, so it will be an electrolyte. So the response thing for electrolyte and non-electrolyte is the ion. Double quit. Okay. For example, NaCl. NaCl, if dissolved in water, it can conduct electricity. But what about solid NaCl? Well, does solid NaCl contains ions? No. Let's open a bottle of solid NaCl. We cannot see any ion. So it cannot conduct electricity. But when we dissolve in water, NaCl, aqueous, it means it dissolved in water, so it can produce positively and negatively charged ion. So in here, which of the following examples can conduct electricity? Actually, both are electrolyte because of this is salt. We know salts are electrolyte, but this is in water. And it contains positive and negative ion, but it does not contain any ion. It's not in water. So it can conduct electricity, but it cannot conduct electricity. So, for a question that asked for which of them can conduct electricity, it should be aqueous and it should be electrolyte. Aqueous and electrolyte. That means all electrolytes, NaCl or HCl or NaOH, okay? If they are not dissolved in water, they are electrolyte, right? But if they are not dissolved in water, so they cannot conduct electricity because of we don't have any ion. But if we dissolve them in the water, so in this case, they can conduct electricity. But in both cases, they are electrolyte. But to have the potential of electricity conductance, it should be in the water to form the ion, and that can swim. Because of the ions need some medium to swim, need a pool to swimming and carrying electricity to a point into another point. Okay, look. Now, the one that can conduct electricity is NaCl is electrolyte, teacher. But it's solid. It cannot conduct electricity. So this is not. NaCl aqueous, yes, it can conduct electricity. Oh, this aqueous also. No. This is true, that's aqueous, but it's not electrolyte, so it cannot conduct electricity. What about? Well, it's not conduct electricity also. So the right answer is C. C is the right answer. Any solution that can conduct electricity must have what? What is the responsible particle in the solution about the electricity conductivity? Iron. Oh, so any solution that contains iron, we call it electrolyte, and it can conduct electricity. Well, this is not important. Now we have this example. Well, using the following examples and then decide which of them can conduct electricity. In here, we don't have any charged particle, so this is non-electrolyte. Because we don't have any ion. A is non-electrolyte, does not contain any ion. But what about here and here? Oh, we have ion in here, and it contains ion also. But in here we have more ion, and here we have less ions. More ions, less ions. Well, both are electrolyte, but this is weak electrolyte because it contains small number of ion. It can conduct electricity poorly, weakly. But in here we have more ions. It can conduct electricity strongly or stronger than the B. And let's see this picture to see the answer. Look. In here, the bulb did not glow. But in here the bulb glows, but very poorly. In here the bulb glows very intensely because in here we have more ions, but in here we have less ions. So this experiment used to identifying a type of substance that is electrolyte or not practically. Okay? This is just like that. Well, about the section 2, we're going to make the investigation of factors that has affected on the rate of the dissolution. Okay? Look, we're going to make the investigation of factors that affecting the rate of the dissolution. We have 3 factors which are increasing the surface area, agitating, and the temperature of the solvent. About the increasing surface area, look, if we talk about a piece of sugar, a chunk of sugar with a powdered sugar, which of them has more surface area? Of course, crushed sugar or powdered sugar. So in here, look, let's put a cubic crystal of sugar into the water. Okay? Only this area exposed to the solvent. Water is a solvent. But if we put powdered sugar into water, we can see that a large area of solid exposed to the solvent. So the rate of dissolution becomes faster. It means increasing surface area increases the rate of the dissolution because of larger number of solute exposed to the solvent. Glass sugar has higher surface area than the cubic sugar. Therefore, the larger number, the higher surface area of the solid exposed to the solvent, that's why the rate of the dissolution is increased. About the agitating, agitating is very simple, okay? When we have a tea to be drinked, so you will stirring using teaspoon. By teaspoon, you're going to stir. Why? Because of stirring makes sugar dissolves faster. Why? Because of, look, this is a cup of tea. It contains a sugar in here. Okay? We will stir this. Okay? Look, this area of the tea dissolves enough sugar and they are saturated. But when we mix, they're going to be transferred to the bottom and a new solvent, a fresh solvent, will be exposed to the solid. That's why agitating makes the collision of a solid to a fresh solvent. Agitating brings a fresh solvent to a solute. Then the rate of the dissolution becomes faster. So stirring and shaking helps disperse the solid particles and brings a fresh solvent that's into contact with the solid. That's why the rate of the dissolution increases. The last one is the heating of the solvent. What about the heating of the solvent? Okay, from now on the answer of heating factor will be started by the increasing of kinetic energy. Anytime when we have a question about the heating, why heating affects that thing, because of, immediately you have to start by the kinetic energy. Because of the kinetic energy increases, so the thing is going to be happened. This is a very good answer for whole of a chemistry, grade 12 chemistry book. Okay, so what will happen when we increase a heat of the solution? Immediately the solid dissolves faster. Because of the kinetic energy increases and the number of collision increases between the solvent and solid, then the rate of the dissolution increases. So, what will be your expectation about the dissolution rate when we put some sugar into cold water and then into hot water? Which of them dissolves sugar faster? Of course, hotter one. Why? Because of it has higher kinetic energy, energy of motion. Then there's more collision between solvent and solid. So the rate of dissolution is faster or is higher. Solubility is the amount of solvent. Well, this is explanation of the solubility. Let's stay at the solubility for some minutes. Solubility, let's explain solubility, is the amount of a substance that required to prepare a saturated solution. A saturated solution. So the explanation of solubility built on the base of a saturated solution. For example, what's the solubility of that compound? Okay, wait, let's prepare a saturated solution of that compound. Put that compound continuously until we will see the precipitate, then stop. And then measure the amount of dissolved by the amount of the solvent. This is the solubility of that substance. Now, what are the factors should be considered when we talk about the solubility? That substance has a solubility 1 gram in 100 grams of water. But we should concern some factors with that. At what temperature, at what pressure? So temperature must be specified and pressure must be specified. But in case of gas solutes, if we dissolve in gas, we should consider the pressure. Okay? And this is, I will leave that for yourself. And now we have a solution equilibrium. What is the solution equilibrium? When we prepare a solution, look, this is a jar, this is a beaker, or it contains some water. This is water. This is water. And let's put some particles of sugar. This is particles of sugar. So firstly, when sugar particles exposed to the water, it means solute solvent collision. If solutes collide by the solvent, it will be dissolution process. Dissolution. But let's add continuously sugar. What will be your observation? Okay, teacher, if we add more sugar, more, then we will see that the sugar particles are settled out to the bottom as a precipitate. Why? Because of there will be more dissolved sugar. When we add more sugar, so that sugar, instead of exposed by the solvent, it will be exposed by its solute. Or it means, look, sugar by sugar. So the collision between will be between sugar solid, this is new sugar, and this is dissolved sugar inside of the solution. So it cannot be dissolved, so immediately it will be precipitated to the bottom. That means if solute, the collision between solute, this is precipitation process. So we have two processes now, dissolution and precipitation. When we have dissolution, if a solute, okay, exposed to a solvent. When we have a precipitate, if a solid exposed by solid. Solid exposed by dissolved solid. So now the equilibrium will be between dissolution and precipitation, okay? Precipitation also called recrystallization in here, okay? Dissolution and precipitation, recrystallization. When we have equal rate between crystallization and dissolution, it will be a solution equilibrium. In that case, we say that it's a saturated solution. Saturated solution. So, quit. Look, what factors determine the point at which the given solid solvent combination reaches an equilibrium, okay? So there's a limit of amount of solid can be dissolved in a solvent, but when we have equal rate between dissolution and recrystallization, so it will be a solution equilibrium. And it depends on the nature of a solid, nature of a solvent, temperature and pressure if a solid is gas. Recrystallization, we know that is a precipitation when a solute, when a solid solute exposed to a dissolved solute. So it means solute by solute, the collision between solute and solid. It will be dissolution or precipitation, of course, precipitation. We have another classification of a solution based on the amount of solute, which is saturated, unsaturated, and supersaturated. So for saturated solution, the solution is at equilibrium. A solution that contains a maximum amount of dissolved solute, okay? So if we dissolve a maximum amount of solid in the solvent, it will be a saturated solution. In that case, we have a equilibrium between recrystallization and the dissolution process. For unsaturated, a solution that contains less solid than the saturated solution, and supersaturated solution contains higher amount of the saturated solution. In here we have recrystallization, okay? Recrystallization. The crystal begins to form, so it will be a supersaturated, or if a saturated solution, hot saturated solution cooled, and a crystal formed, it will be a supersaturated. So supersaturated contains the largest amount of a solid by comparing with the saturated and unsaturated. Well, this is very simple how to prepare a types of solutions, saturated, unsaturated, and supersaturated. I will leave it for you. But how we can identify the type of a solution? Look, how we can identify a type of a solution. If we add a solute, look, we have a solution in here. Okay, I'll tell you. This is sugar in water solution. Sugar H2O solution. Identify that is saturated, supersaturated, or unsaturated? Okay, it's very easy. I'm going to taste it. Okay, taste it. You're going to feel a sweet taste, but how do you know it's saturated, supersaturated, or unsaturated? You should prove that practically. So let's add more amount of sugar, some drops of sugar. If it dissolves it, immediately you have to say this is unsaturated. It means still it's hungry, needs to dissolve more. So when a solid is added to the solution, then it dissolves, it will be unsaturated. It means the solution still is hungry. It has the ability to eat more solid. So if the solid is dissolved, it means it's unsaturated. But what will happen if it precipitated? Oh, this is not hungry, it's saturated. It cannot dissolve more, so it will be precipitated. So if a solid is added, but it not dissolved, it precipitated, so this is saturated solution. But what will happen if we shake it, or if we stir it immediately, the crystal form it without adding more salt. Look, to identifying that is supersaturated or not, take a solution of sugar in water without adding any more solid. Just shake it. If a crystal form it, this is supersaturated. Or if the solution is cold and we cooled it down, and again, if a crystal form it, it's a supersaturated. Okay? So which of the following solutions form the precipitate? It means without adding a solvent. Without adding a solvent. Which of them has the ability to form a crystal? Supersaturated. But if a question says that which of the following solution forms a precipitate when we add more solute, of course saturated has that potential, and supersaturated also can do the same. But without adding a more solute, just it can form a crystal by itself without adding any more solute, so it will be supersaturated. Now we have some mathematical questions about the solubility. Well, I'll solve just two of them, and the others I'll leave for you, okay? So we will need some minutes for that. If KClO3 at 25 Celsius degree, the solubility of KClO3 equal to 10 grams per 100 grams of H2O. 10 grams per 100 grams of H2O. It means if we have 100 grams of H2O, it can dissolve 10 grams of KClO3. That means, okay? Look, solubility of KClO3 is 10 grams per 100 grams of H2O. It means 10 grams of KClO3 can dissolve in 100 grams of water. Okay? Look, if we add 50 grams of KClO3 to 100 grams of water, so show us the amount of KClO3 that can be dissolved and the amount that can be precipitated. Look, we have 100 grams of H2O. It can dissolve how many grams of KClO3? 10. But we have 50 grams. So 10 grams is dissolved and 5 grams can be precipitated. So because of we add more solid and it forms a precipitate, so the solution is saturated. Saturated. Another question. If we add 50 grams of KClO3 to 100 grams of water, 100 grams of water can dissolve 10 grams. But what about 200 grams of water? It can dissolve 20 grams. But in here we have 50 grams. So all of the amount of KClO3 can be dissolved and the solution is unsaturated. Okay? Well, it doesn't need to be right. The solution is unsaturated. It's very easy. Now we have the rule of lag dissolves lag. Actually, it's very important. The rule of lag dissolves lag, it relates to the polarity. Rule lag dissolves lag, it relates to polarity. Okay, this phrase used by the chemists as an approximation rule to predict or to make the prediction of the solubility between the compounds. For example, we have some compounds in laboratory that can dissolve in the other, and we have some compound that cannot dissolve in the other. So how we can discuss this phenomena? Okay, look, polar compounds can dissolve in polar compounds. It means polar can dissolve in polar. Non-polar compound can dissolve in non-polar compound. But what about polar and non-polar? No, there will be no dissolution process. So polar with polar, non-polar with non-polar. Polar can be miscible with polar, non-polar can be miscible with non-polar. Okay. What makes substances similar? What makes substances similar? There are some substances. It means similar substance can dissolve in similar substance. So what makes substances similar? There are some factors that are responsible of similarity between the compounds, which is the type of bonding and the polarity and the intermolecular force. Such as an example of intermolecular force with London dispersion force is the weakest force between non-polar compounds. We've learned that in grade 11. Now, before going to study that, we have to learn this table. It's very important. No, it's super important. We have to recognize non-polar compounds and polar compounds, and there's a bridge between them, which has a relation between polar and non-polar. Okay? Non-polar compounds are benzene, gasoline, kerosene, oil, lipid, fat, toluene, and carbon tetrachloride. For polar compounds, water, acid, base includes strong and weak. Salt, sugar, okay? Alcohol also, they are polar compounds. But there's a bridge, which is weak polar compound, ethanol. Ethanol consists of non-polar end and polar end. It's very important, please be aware about here. Look, benzene can dissolve kerosene because of both are non-polar. Kerosene dissolves oil. Oil dissolves benzene. Benzene dissolves toluene. Toluene dissolves carbon tetrachloride. Carbon tetrachloride dissolves benzene. Why? Because of they are non-polar, so they can dissolve in each other. In here, in contrast, water can dissolve in the acid. Acids can dissolve water. Acid can dissolve bases. Salt, water. So each of them can dissolve each other because of they are polar compounds. Okay, but what about water and benzene? No, they cannot be miscible, and benzene cannot dissolve water, water cannot dissolve benzene. Why? Because of benzene is non-polar, water is polar. Okay, but we have a substance, that can make a relation with both of them, which is ethanol. Ethanol contains a non-polar end and polar end. Because of non-polar end, it can dissolve non-polar compounds, and because of the polar end, it can dissolve polar compounds. So ethanol can dissolve this side and dissolve this side. Why? Because of it contains both polar and non-polar end. Now, let's answer some questions about that. Okay, here is good. Why does sugar dissolve in water now? Why sugar dissolves in water? Immediately we have to mention the polarity. Well, I don't know sugar is polar or not, but question says it dissolves. So it means both must be polar or non-polar. We know that water is polar, so sugar is polar also, because of both are polar. Why LiCl cannot dissolve in toluene? Oh, I don't know LiCl is polar or not, but I'm sure that toluene is non-polar. Non-polar. And question says that cannot dissolve, so it means the other one must be polar because of toluene is non-polar. So toluene is polar, LiCl is polar and toluene is non-polar, so they are different from the type of bonding and the intermolecular force. ethanol is a better solvent than water for less polar compound. It talks about less polar compounds because of ethanol contains a non-polar end. That's why it can dissolve less polar compounds. Look, because ethanol molecule has non-polar end region. Why ethanol and methanol? Methanol is the same case also as a methanol, are dissolved in water. Oh, water is polar because of they have polar end, so they can dissolve in water, or they can dissolve water also. Ethanol is a solvent for polar molecules. Yeah, it has a polar end. Non-polar molecules, yes, it has a non-polar end. Polar and non-polar, yes, the right answer is B. Okay, the right answer is B. Now we have miscible liquids and immiscible liquids. Miscible liquids, it means we have two liquids that can be miscible in each other by any quantity because of both of them must be polar or both of them are non-polar. Okay, so they can be miscible together and living together. For example, water and alcohol, they can be miscible after mixing them together because of both are polar. But what about water and kerosene? Okay, a heating fuel. A heating fuel, kerosene and water, they cannot be miscible. Why? Because of water is polar and kerosene is non-polar. So that's all about miscible and immiscible liquids. Which of the following mixture components can be miscible in each other? Fat and benzene, both are non-polar. Yeah, they can be miscible. This is true. NH3 and water, NH3 is base. Water, so it's polar. Water is polar, so they can be miscible. This is true. Water and ethanol, yeah, it's true. So the right answer is all of them. Now, we have a hydration and the solvation process. A hydration, it means when we dissolve some compound in the water, hydration came from a water, okay? When we dissolve some compound in water and it will be surrounded by water molecules, so this is hydrated. Look, we dissolve it. I prefer to use this picture. It's better than my drawing. Okay. We put some LiCl in the water. LiCl is a salt. It can produce positively charged and negatively charged ion. Okay? So they will be surrounded by water. They will be surrounded by water. The process is the hydration, dissolving any substance in water to form aqueous solution. This is a hydration. But that particle which is surrounded by water, it's called hydrated. Hydrated. So hydrated, it means any particle, any ion that's surrounded by water. Surrounded by what? Water. So it will be a hydrated. A hydrated. But what will happen if we have some compound surrounded by solvent particles? It's not identified that is water or not. So what we call this particle, this is solvated. Because of it dissolved in a solvent, so it will be solvated. Solvated. So if a solvent is water, it will be hydrated. But if a solvent is not water, it will be asolvated. So this process always is exothermic, releasing energy. Releasing energy. Okay? And now, the factor that affects the solubility of gas in liquid. This is very important to discussing solubility in gas and liquid. Well, before doing that, let's talk about the effect of pressure on solubility. Pressure has a very little effect of the solubility of solid and liquid in each other. Pressure about the solid and liquid in each other has a very little effect. But about the gas in liquid, it's extremely pressure dependent. Increasing pressure increases solubility. Decreasing pressure decreases solubility. So we have a special rule that governed this process, that arranged this process. This process supervised by a rule of Henry's law. Henry's law. What's a Henry's law? Okay, Henry's law states that the solubility of gas in the liquid. Solubility of gas in the liquid increases with increasing the partial pressure of the gas on the surface of the liquid. So Henry's law related to what? Solubility of gas in liquid. In here, write down gas in liquid. It will be discussed by Henry's law. Henry's law. So Henry's law related to the solubility of liquid in liquid? No. Solid in liquid? No. Solid in solid? No. Gas in liquid? Yes. Gas in liquid is the right answer. So pressure has effect only on the solubility of gas on the liquid externally. Okay, but about the solubility of liquid in liquid or solid in liquid has a very low, has a very little effect. But it has a very big effect on the solubility of gas in the liquid. Why? I'm going to show you why. Look, this is a beaker containing some liquid. Here is O2 gas. O2 gas. And now let's increase the pressure. So we have a rule to discussing this process, which is Henry's law. Henry's law says that increasing pressure increases the solubility of gas in the liquid. Why? Because of if we increase the pressure, okay, look, the particles of oxygen starts to enter to the inside of the solution, to the inside of the solvent, because we just pressed the particle of O2 into the liquid, into the solvent. So when the particles of O2 start to entering the liquid, immediately that liquid going to do something. Oh, I received some O2 from the outside. Immediately they're going to be arrested by the attraction force of the solvent. So that O2 enters to inside of the solvent and it's arrested by the attraction force of the solvent. So this process called gas dissolving process. Okay? Look, pressing O2 into the liquid, so entering gas molecule into the liquid, it's called gas dissolution. Entering gas molecule into the liquid called gas dissolution. So what about escaping gas molecule into the liquid, into out of the liquid, called what? Called effervescence. So effervescence is a reverse process of the gas dissolution. This is reverse process of the gas dissolution. So if the gas molecules enter to the liquid, it will be gas dissolution. So what about escaping them? It's effervescence. It's effervescence. So effervescence is the rapid escaping of gas from the liquid, okay, which dissolved by decreasing, which is happened by decreasing pressure. Well, it's talked about Pepsi. Before removing the cup, the pressure of inside of the Pepsi, pressure of inside of the Pepsi bottle is 5 to 10 atmosphere. But when we remove the cup, the pressure immediately will be decreased. So the effervescence begins to start. Immediately we will see the foam going to out of the bottle. Okay, so this is effervescence. Effervescence is a reverse process of a gas dissolution. Never forget that. Look, I'll show you something. This is effervescence. And in here we have gas dissolution. Gas dissolution. Okay? Increasing pressure, the gas dissolution increases. Increasing pressure. So the effervescence decrease. But what will happen if we decrease the pressure? The gas dissolution decrease, effervescence increase. So there's a exactly reverse proportion relationship between them. Now, let's study effect of pressure on the solubility, effect of temperature on the solubility of gas in the liquid. Look, did you remember what I told you about the effect of temperature in a prior lectures? I told you that when we talk about temperature, immediately you have to say, because of increasing temperature, increases the kinetic energy, energy of motion. That's why the thing begins to happen. Look, increasing the temperature usually decreases the solubility of gas. Why? Did you remember when the gas molecules enter to inside of the liquid, they are arrested by the attraction force of the solvent. So if they begin to moving fastly, okay, they can escape from this attraction force to out of the liquid. Look, if the particles that are arrested by the attraction force of solvent move fastly, they can escape from this attraction force, so it will be effervescence. Now, how we can increase the movement of these particles? Using the temperature. So increasing temperature usually decreases gas solubility. Why? Because of the kinetic energy increases. Look, the kinetic energy, energy of motion increases. So they have able to be escaped from the attraction force of the solvent particles. So which of them has the higher phase or effervescence? Cold soda or hot soda? Okay, because of in hot soda we have less solubility, so there's a highest effervescence. But in cold soda we have more solubility, so the effervescence is decreased. So which of them phases more, cold or hot? Of course, warm one, because of the solubility decreases with the increasing temperature. So if solubility decreases, effervescence increases. There's a reverse proportion relationship between them. So increasing temperature increases the solubility. Increasing temperature increases the solubility of solid. But this is very well. I don't like to talk about that because we don't have much more time. Okay, it's very good. Now let's talk about heat of solutions. When we make some solution, of course the energy is given up or energy is absorbed. So there will be energy change. Okay, before starting to dissolving, this is very good picture. It helps you to be understand very easily. Before starting to mixing solvent with solute, we have the attraction force between solute, and solvent. So it will be breakup, and so the first step is expanding solvent. It means separating solvents into its individual particles. And solid also separated into its individual particles. This process leads to absorbing energy. So the first step, separating particles from each other, is energy absorbent. And then they are ready to reform a bond together. Solvent can form a bond with solute to form a solution. So this process is exothermic, or it releases energy. So the first step, separating particles in each other, I mean solid, solvent, is absorbing energy. And the second step, when the bond begins to reform, is a energy release. It can release energy. When solid and solvent starting to form a bond, it will release the energy. Now, let's talk the overall energy of the process. It's exothermic, delta H is negative, or it's endothermic, delta H is positive. Exothermic or endothermic. If the energy of step 1, okay, step 1 absorbing energy, if the energy is of step 1 is bigger than the energy of step 2, so the overall, if the energy of step 1 is bigger than the step 2, so the overall is endothermic. It means the energy of separation of particles from each other is bigger than reforming the energy of bonding, so it will be endothermic. But if the energy of step 2 is bigger than step 1, so the overall will be exothermic. It means if the energy of solute is bigger than solute and solvent, so it will be, if this energy bigger than this, it will be exothermic. But if that one bigger than that one, it will be endothermic. Simply. So it's all about that things that I said. And now we have some questions about that. Look. Now, negative is releasing energy. Positive is absorbing energy. So the biggest negative is the highest amount of energy that releases it. The biggest positive is the highest amount of energy that absorbs it. Which of the following energy values indicates the most amount of energy that is, indicates the most amount of energy that's released. It means the biggest negative. So this is the right answer. Solubility of gas and liquid with increasing temperature, decrease it. Okay, decrease it. Gas and liquid with increasing temperature, the solubility decrease, but the effervescence increase. Increasing temperature, effervescence will be increased. You know that. Okay, I prefer to enlarge the page. Okay. A solution contains, a solution contains more dissolved solute. When a question says more dissolved solute, it means concentrated. Concentrated. Little dissolving solid, it means diluted. Dilute, okay? A solution contains more dissolved solid, it means it concentrated. And cannot dissolve anymore, it means saturated. So the right answer is saturated and concentrated. A solution contains more dissolved solid, it's concentrated. And it can dissolve any more solid. It's concentrated and unsaturated. So the right answer is unsaturated and concentrated. In here we can see that there is no relation between concentrated and saturation. Concentrated, it means more dissolved solute, but saturated, it means have not ability to dissolve more solute. And less dissolved solid, it means dilute, but unsaturated, it means has ability to dissolve more. Okay, and we will start to study of section 3 in a new lecture. دیوادارم سوتان لێبینی بێ ئینشاءالله لەوانەی داهاتوو دەست دەکەین بە خوێندنی حسابات دەربارەی خەستی concentration. تاو کات بەخواتان دەست پێرم خواتان لەگەڵ.